Hi, welcome to this session. Today we are going to talk about pointers in C++. So pointers are one of the most important concepts in C++ and are used to directly manage and manipulate memory. While this may sound advanced, the core idea is simple. So a pointer is a variable that stores the memory address of another variable. We would like to illustrate this using an example. But before going through the example, we would like to review some part of the code. So we know how to initialize and declare one variable of type integer. For example, we assign the value 10 to the integer named x. And then we are going to print the output using cout syntax. So when I run, I see the value of x equals 10, which is the assigned value. But this value, when it is declared, it is stored somewhere in the memory. When it is stored somewhere in the memory, and if we would like to find the address where this integer is exactly stored, we can simply type a syntax call like and the name of the integer that is declared above. So here by having this line, we are able to find the address of the integer x. So we are going to find exactly where this x is stored in the memory. Let's run. Okay, so this is the address of the variable x that is equal to this line. So this is the address where it is stored. Now in pointers, we are going to assign the address of a variable to a pointer. So the pointer can store its address, and it can directly use the address to modify or manipulate the variable. Here, we would like to write a program that demonstrates the use of a pointer to store and retrieve the value of a variable. In order to do that, first we declare and initialize a variable here. And what we're going to do is the following. So we are giving the address of the variable to be equal to the pointer that is defined here. But how do we know that it is a pointer? Because there is one star before the name of the pointer. So when we have this type of declaration, it means that it's a pointer. And we are simply just giving the address of the variable x here. So far we printed the value of x, the address of x, and now we are going to print the ptr variable that is assigned the address of x. As you see here, when we are printing the ptr, it exactly equals the address of x because this is what it is assigned to. So this ptr, this pointer, is directly accessing the address of where x is stored. However, if we are going to use a pointer that is shown by star then ptr, we are going to access the value of the variable x. So we expect to see number 10 when we print this line here. Let me run. Great. So we first printed the number of the variable, then its address, then using the address that is stored in the pointer using ptr, we printed the address in which the x variable is stored. Then in order to access the value of x, we simply use the dereferencing the pointer, which is star then ptr. So we can now see that we are having access to the variable x. So now we can see that the variable x is declared, its address is given to a pointer, and the pointer can access the address of x using only ptr. And if we are dereferencing the pointer, meaning that we are having a star behind it, it means that we are directly accessing the value of the assigned variable. So this is just a beginning and introduction of pointers. Please go ahead and do this very simple exercise for yourself and try to play with it. It gives you a good introduction for starting this section of pointers. In the next sessions and videos, we are going to dive deeper into different examples and coding exercises of pointers and show how they are useful. Thank you for watching. Hello everyone, welcome back. In today's lecture, we are going to do one coding exercises with respect to the pointers. We would like to write a program that defines a function to double the value of a variable using a pointer. Previously, we know how to do it using a call by reference. However, here we are going to do it directly with a pointer. To do that, first we are going to initialize one integer called x to be 10, and we are going to print its value before doing any modification. So we expect that it will print the value 10. Then we are going to call our function. So when we are calling the function, we are passing as the argument, we are passing the address of the variable x. How do we know that we are passing the address? Because we are having this and sign before the name of the variable. So let's go up. So here we see that the name of the function is double value. It's of void type, so it's not going to return anything. And as an argument, it is accepting pointers. So when we are passing the address, this function is going to have access to the memory address, to the memory address of where this variable x is stored, and it can also do modifications to the value of x itself. So what's going to do is that it is going to, whatever the value of that x is, showing this star ptr, is going to be multiplied by 2, and it is going to store here. So basically we learned that when we have something like this, we can also write it like this. So writing it like this is more advanced, but we can also see this equation with this line. So it's only your choice, but you're going to see this example more frequently. So basically, whatever the value of star PTR is, in this case, it is 10, because the address of the variable x, which is 10, is passed as the argument. So the star PTR is going to access the value of the variable itself. When it is PTR, it is going to have access to the address. When it is star PTR, it is going to have access to the value. So here we are having star PTR dereferencing the pointer. So the value of x is being multiplied by 2, and it is being stored in the x. So 10 times 2 means 20. So 20 is going to be stored in the different dereferencing the pointer. So in the PTR, star PTR, which means x. And when this function's work is finished, the execution of the code finishes this line and is going to the next line. So here we are saying after doubling the x. Let me just compile. Great. So as we discussed, 10 is assigned to x. We are printing x before doing any modification here. Then we are calling the function and passing the address of x as an argument. So when we have access to the address using a pointer, we can access to its address using the PTR or star PTR to have access to the value. In this case, we use the star PTR, so this means that we are having access to the variable x. its value is 10, so 10 times 2 means 20, so 20 is assigned to a star ptr or x. So basically this line is exactly like writing x times 2. So it means that we are having 10 times 2 equal x equals 20. Okay, so this is what it means. So we see that using a pointer, we can do some direct modification without having the call by reference here to any variables in a function outside of the main function. Thank you for watching. Hello everyone, welcome back. We are going to do another coding exercise using a pointer, and we would like to write a program that uses a function to modify the value of a variable using a pointer. To do that, we know that we need a function to do that for us, but in the int main function, we first initialize one variable named x. Then we are going to print the value of x before doing any modification, and we expect here to print the value of 25. Then we are going to pass the address of this x variable to this set200 function. So this set200 function, the name is set200. It's of a void type, and its argument or its input is a pointer. So by passing the address of the variable x, this function can have access both to the address and to the value of the variable x here. So here, this function is going to simply put 100 to the variable x. Why we are saying that star ptr means variable x? Because we are dereferencing the pointer here, and the pointer is pointing to the variable x. Why? Because its address is passed. When its address is passed, and if we use ptr, it's going to print the address. When we use star ptr, we are going to have access to the value. So now the pointer, when we call this function by its address, the pointer is pointing to this x variable. And now we are saying that, okay, now assign 100 to that x variable. This line simply means that we are going to put x to be equal to 10, but to 100. But if we want to do it directly with a variable, we need to do it by a call by reference. Using a pointer, we can directly access the value of the variable and make some modification here. So let me just now run and you will see the result. Okay. So here we are initializing the variable, we are printing its value, it is 25. Then we are calling the function and we are passing as the argument, we are passing the address of this variable x. So it basically means that this pointer is pointing to this variable x. By using the star ptr, we are dereferencing the pointer, meaning that we are setting the 100 to this star ptr. It means that we are putting 100 to the x variable directly. And then we are printing the variable x after call the function. Please note that we couldn't directly modify the variable x using this line, because if we wanted to do so, we had to use a call by reference. It is a very important just note to have in mind that we need a call by reference to directly modify this variable x here, or we can do it using a pointer as we mentioned in here. Thank you for watching. Hello everyone, and welcome to another session. In today's session, we are doing a coding exercise using pointers and functions. We would like to write a program that swaps the value of two variables using a function and pointers. We learned previously how to do it using a call by value or a call by reference. So a call by reference, we can directly modify the variables but in a call by value, we are modifying a copy of the original variables. So whatever that is printed in the function is the modification, and the modification is not done in the int main function. So this is what we learned from the C++ course beginners. Now we are going to do modifications using a pointer. So in order to do that, we declare two variables, x and y, and we would like to swap their values. So now we are printing the x and y values. We expect that it should be 5 and 10, x equals 5 and y equals 10. Then we call the swap function here, and we are passing the address of the x and the address of y. So this function is going to have access to the address of both variables and directly to the values of both variables. So this function is called swap. It's a void type, and it is accepting two arguments, two pointers as the arguments, and they are separated by a comma. In order to swap their values, we are defining a new variable called temp, means temporary. So the first argument here represents the x, and the second argument here represents the y. So star A, so pointer A is having access to value x, which is 5, and pointer B is going to have access to the value 10, which is y. So now when we say star A, it means x or it means 5. So star A is assigned to this temp, meaning that 5 is assigned to this temp. And then star B is assigned to star A, meaning that 10 is assigned to star A. And finally, temp is assigned to star B, meaning that because it got the value of 5. So 5 is assigned to star B. Basically, we defined a new variable. We put whatever it is in A, we are putting in this one. And then we are putting whatever that is in B in A. And then we are putting this temp into B. So we used a third variable to swap the values of these A and B. And after this function has finished its execution, we are going to print the value of x and y, and we see that the values are swapped directly. Okay, great. Let me analyze the code for you one more time. So we are having two variables here, and we are printing their values. X equals 5, y equals 10, so we are printing them. Then we call the swap function. It's a void type. We are passing the address of two variables, x and y. So A represents x and B represents y. So whatever that is in A or x, or simply means 5, is going to be assigned to temp. And then whatever that is in star B simply means y, or 10 is going to be assigned to star A, meaning that x is going to get the value 10, like this. And then temp was 5. Now then temp is going to be assigned to star B, meaning that 5 is going to be assigned to star B, meaning that now 5 star B equals 5 and star A equals 10. So initially star A was representing x, whose value was 5. Now it is still representing x, but its value has changed. The same goes with the B, as we see the result here after swapping x equals 10 and y equals 5. It's a very good example that we can do modification using a pointer directly directly pointing to the variables. Don't forget to do these exercises yourself to get used to syntaxes of the pointers in C++. Thank you for watching. Hello everyone, welcome back. Now we are we're going to do another coding exercise using pointers. So we would like to write a program that using a pointer we are going to print an array and access all the elements of array. So write a program that access an array and print its elements using a pointer. So this is what we are going to do. We know how to initialize an array. So it is an array of type integer. There are 5 elements in this array. And we are pointing to the first element of the array. So the first element of the array is, this is how the first element of the array is accessible using a sign and a sign here and a sign here before the name of the array. We are basically having access to the address where the first element of the array is stored. So we are giving the address of where the first element of the array is stored. So using this line, we are pointing to the first element of the array. So the pointer knows where the first element of the array now is stored. So now, in order to make some clarifications, let me print the PTR. So only the PTR, and then the address of the first element of the array. So we expect that they should be the same. Okay, great. So they are the same. Why? The reason is we are giving the address of the first element of the array, the value 1, to this pointer. So when we are using PTR, it is going to print the address where the first element of the array is stored in, and using this line and ARR and 0, we are going to print the address of where the first element of this array is stored in the memory. So we see that everything works perfectly, and now we are going to print the value of the first element of the array just using the array syntax directly, and also using the dereferencing the pointer. Using a pointer, we are going to print that. We expect the values should be the same again. Okay, so we see that we wanted to assign the pointer to point at the first element of this array, and we see the first value is 1. Using this line, it is printed, and the pointer is also pointing to the value, the first element of the array, whose value is 1. So the pointer works perfectly and everything is good now. So let us now print the elements of this array using the pointers and for loops. To do so, we know, because we need to iterate over all the elements of the array, we need a for loop. And a for loop is going to start from 0 until I is lower than 5. So basically, this means that I equals 0, I equals 1, I equals 2, I equals 3, I equals 4. And there are 5 elements in the array, so this represents the first element, second, third, fourth, and the fifth element. So we are going to print element I plus 1. Why I plus 1? Because I equals 0, but because C++ starts from 0, we can simply just add 1 to show that we are talking about the first element. And then, because we would like to print the value, we are going to print the value of the first element of the array plus I. That plus I means, let me just type down the details so you would have a better understanding. So now I plus 1 is printed. And then we have the star PTR, the pointer, plus I. So this means that when I equals 0 in the first iteration, 0 plus 1 is printed, and then the pointer is 1. The pointer is pointing to the first element now because I equals 0, so the pointer is going to pointing at the first element. So basically, now let me just run and see the first line result. Let me just comment this part so it would have a more clean output. So we see that when I equals 0, it is printing the element 1, which is this part, element 1. And we are pointing at the first element whose value is 1. And then we see here that the pointer is pointing to the first element, and no value is added to this because I equals 0. So it is still going to point at the first element. When I equals 1, we will have element I plus 1. This means that I equals 1, so 1 plus 1, this means 2. And then pointer is already pointing at the first element plus 1. So it is going to point at the second element this time. So let's compile. As you see here, when I equals 1, so we are having the element 2, and pointer was already pointing at the first element. Now I equals 1, so I is added to the pointer, so pointer is going to point to the second element. So then I equals 2, element 2 plus 1 means that it's 3. Pointer equal to 1 already in the initialization. It is going to have access to this one, and it is going to be added by 2 because of this line, because it is added by 2. Now I equals 2. So pointer is going to point to the third element. So let's run. Great. We see in here when I equals 2, we have the element 3. So element 3, and pointer was already pointing to the first element plus I, and I equals 2, so it is going to point to the third element whose value is 3. So using this loop, and then I equals 3 and I equals 4 as well. So we see that using a pointer, we can iterate over an array and access to all the elements of array, and we learned how to point to the first element of the array. And if we would like to, for example, have access to the second element of the array using a pointer, for example, now the address of the second element of this array, which means 2, is being assigned to the pointer. So pointer now is pointing to the second element of the array. But because for the sake of simplicity, we started with the first element. Depending on what you want to do, you can simply change the pointer is pointing to which element of the array. Thank you for watching. Hello everyone, welcome to this coding session. In today's coding exercise, we would like to write a program to access and print the elements of a two-dimensional array using pointers. But before doing that, I would like to review some concepts of the pointers in C++, and then we will dive into solving this program. So we learned how to define and initialize a variable, and then pass the address of the variable to a pointer. And we learned that if we dereference the pointer here, if we dereference the pointer, we can access the value of the variable. And if we simply use PTR, we are going to have access to where this pointer, this variable is stored in the memory. So this line is going to give us the value of the variable x, which is 10, and this line is going to give us the address where this variable x is stored in the memory. Let's run. Great. So we see here that the value of x is printed, which is 10, and then the address is printed here. Okay, so this is a simple example to just review the concepts. Now we would like to dive into the coding exercise. Okay, now we would like to have a two-dimensional array just like this. Let me just comment the above part because, yeah, okay. So here we are initializing one matrix, two-dimensional matrix. There are two rows. There are two rows here and three columns, and there are elements associated to each row and column. So each cell has one associated value there. So in order to have a pointer to this array, things are a bit different. So in order for a pointer to point to this array, we are writing int the type of the pointer. So in parentheses, we write down the star ptr, and then we type the number of columns of that array equals to the name of that array. So this is how we are going, in this way, we are going to store the address of the first row of this two-dimensional array matrix. So this line is going to help us to have the address of the first row of this matrix. And since PTR points to the entire row, so this PTR is pointing to the entire row, we must access elements using PTR ij. So indexing is necessary. So indexing, when we have the indexing, automatically dereferencing the pointer and we can access specific elements using star PTR, like here, would give the entire row of the array and not a single element here for the array. So previously, when we were having star PTR dereferencing pointer, we were having access to the value of x, but because it was a single element, here we have a pointer that is pointing to the full row, to all these three numbers. Therefore, we must use the PTR I and j to point at each specific cell, each specific value. So, for example, if we type down PTR 00, it is going to point here. But if we type down PTR 01, like this, 01, it is going to point to number 2. So therefore, it is necessary to point at each element using this formula. And you see that initializing the pointer for a two-dimensional array is a bit different. Here, in order for you to have a better understanding, I am printing two values. Above, we printed the same syntax when the pointer was pointing at one single element. But here, if I run, you see in both cases, it is just returning the address where the first row of the pointer is stored. So either using star ptr dereference pointer or simply the ptr, it is going to give us the address. But how can we access the elements? In order to access the elements, as I mentioned in above, we need to use ing. To do that, we need to have a for loop, a nested for loop. So the outer loop is going to point to the rows outer loop, and the inner loop is going to be for the columns. So now in order to print the data, for example, in the first time I equals 0, j equals 0, we are going to print ptr00. Then I still, for this line, I equals 0 everywhere, but j now equals 1. We will have the ptr 0, 1, and then j equals 2. We will have ptr 0, 2. So we are going to have the prints of 1, 2, and 3. Why? Because ptr00 means that the pointer is pointing at the first row, first element here. So the value of 1 is printed. Sorry, the value of 1 is printed. Then 1 space is printed here. Then I is still 0, j equals 1, so pointer is pointing at the first row, second column, which is 2 here, and then first row, third element, 3. So when j reaches the number 2, this loop is not going to be repeated. Why? Because when we increase the value of j to 3, 3 is not lower than 3, so it's not going to pass this condition and it's not going to enter this inner loop anymore. We have one endl here, so we are going to next line, and now I is increased from 0 to 1 by 1 value, so I equals to 1, and again j equals 0 until 2. So it is going to basically print first this line, this number, and then this number, and then this number. And how we're accessing it, using simply ptr ing. So this is how we're going to have access to elements of a two-dimensional array. Let me run. Okay, great. So let me just comment this part so we will have a clean output. Great. So here we see that we are able to print the value of this two-dimensional array. And simply the way for doing this using a pointer is that we type the name of the matrix, we type down the number of column, and dereferenced pointer in parentheses, and then the type, and then simply just print it using ptr and ing, that are the row and columns in the two-dimensional array matrix. Thank you for watching. Hello everyone, welcome back. In today's coding exercise session, we would like to write a program to change one element of a two-dimensional array and print the elements of it. So we learned how to initialize one two-dimensional array. So here we are having 2 rows and 3 columns. And we're defining a pointer that is pointing to the first row of the array here. So it is pointing now to this part. And to do that, we need to have the number of columns when initializing the pointer. In order to access elements of a two-dimensional array using a pointer, we learned that we need to do it using ing. So now that we would like to change, for example, this value, instead of having 6, we would like to have 7. So we are going to type down the second row, and the third column should be, for example, 7, or should be 9. Okay. And then in order to print again the two-dimensional array, we need one outer loop representing rows and one inner loop representing columns, then simply using ptr I and j. So now if I run, you will see, okay, great. So the original array was 1, 2, 3, 4, 5, 6, but the modified array is 1, 2, 3, 4, 5, 9. Why? Because we directly changed the value of the second row, third column here. It was originally 6. Using this line, we changed it. So this was a good example of how to modify one element of a two-dimensional array. Please go ahead and do these exercises yourself to get used to defining a pointer pointing to a two-dimensional array. And also, if you haven't had the chance to rate this course, we would appreciate it if you could do it for us. It would be very beneficial for us. And also, we would appreciate if you give us some constructive feedback. It can help us to improve our teaching experience and having a better courses for future students. Thank you. Hello everyone, welcome to another coding exercise. In this session, we would like to write a program that defines an array of functions pointers. So let us dive into it right away to see what we mean by functions pointers. So here it is our main function here. We are declaring an array of function pointers. So here I have 4 functions. The first function is add. It's of type int. 2 arguments are there. Both of them are integer, and it is going to return, because it's not a void type. It's of anything apart from void. There should be one return. So it is returning a plus b. Then we have the subtract function. It is basically the same thing, but it is going to return a minus b. Then multiply function that is going to return a multiplied by b. And then we have the divide function. First we check to see if the b is equal 0 or not. If it's not equal to 0, the second number, we are going to return a divided by b. Otherwise, if b equals 0, we're just saying that division by 0 is not allowed, so we return an error. Okay, so these are our 4 functions that we defined: add, subtract, multiply, and divide. So these 4 functions their names are defined like an array, and we have a pointer pointing to these 4 functions. Basically, we are having of type integer. This is our dereferenced pointer. There are 4 elements in it, and the 4 elements are these 4 functions, and the arguments are 2 arguments separated by a comma, and both are of the type integer. Now, the function pointers are defined, and now we have 2 variables. The first one is x, the second one is y. We're going to set 10 to be equal to x and 5 for y. And in order now to call the function using our pointer, we can simply do it like this. So just imagine that we have, this is the first element, this is the second element, third element, and the fourth element. Okay, and we start from 0 in C++. So in order to call the first function, the add function, its index is 0, so we're going to use 0, and then the name of our pointer, we are simply just using the name of the pointer directly, and we are passing x and y as the arguments. We can define any other variables like z, I don't know, h, whatever, So we can just pass two variables to the first function of these function pointers. So the first function is add, and when we are saying 0, it means that we are talking about the add function and we are using our pointer name. So it directly goes and pass the x and y to the add function, and here it's going to calculate the a plus b and see out the value for us. Let me just run the code. Okay, so a plus b is 15. It's correct. So now what if we would like to call subtract? So we simply just point to the second element with the index 1. Okay, it is going to do the job for us. And if we would like to, for example, do the division, we are going to now have the division result. Okay, it's 2, so it's correct. 10 divided by 5, it's 2. But in order to avoid repetition, we can call all the functions together. To do that, we need a for loop. In our for loop, we are going to start from 0 and we will go up until I is lower than 4. So here we are calling the functions one by one. When I equals 0, this place will be operations 0. So add function is called. Then I equals 1, operations 1. So the subtract function is going to be called. What I mean is something like this. When I equals 0, I equals 0. For example, I equals 1, we have the operations 1, so subtract is going to be called. Then we have operations 2 when I equals 2, for example, and then I equals 3. We have operations 3, and the divide function is going to be called, and after each call we are going to the next line. So this line is going to print result of operations. We are calling the number of the element, so we are adding 1 because it is starting from 0. We would like to have from 1 to 4. So we have, when it's 0, it is printing 1, and then 2, 3, and 4. And then we are calling the functions one by one: add, subtract, multiply, and divide, and passing the argument x and y and print the result because we are using the cout. Let me run. Okay, great. So here we see first it does the a plus b, so it calls the add function, it's 15. Then do the subtract, it's 5, 10 minus 5, then 10 times 5, it's 50, and then 10 divided by 5, it's 2. So simply we can have, in order to facilitate our coding, we can, instead of, for example, having 4 pointers and each pointer is pointing at one function, we can have only one pointer, and this pointer is pointing at an array of functions, and different element of this array is one function. So the first element is one function, the second element is another function, the third element is another function, etc. This way, we can save a lot in our memory usage when we are having a long blocks of code, too many blocks of code. So this is going to help us very much. Thank you for watching this video. Hello everyone, welcome back. In today's video, we're going to do one coding exercise, and we would like to write a program that defines an array of function pointers. We did the same thing in the previous exercise. However, in this exercise, we are going to read some values from the user. So we are going to get some values from the user and use those values in order to do the operations. So we basically have the same functions here, and we are having the same function pointer here. and we have a display menu. When we run the program, we are asking select an operation. So the user is going to select add if they want this. They are going to select one if they are going to use the add function. And if they're going to use the subtract function, they are going to enter 2, enter 3 for multiply, enter 4 for divide. And this code is simply just the number. Look, see here, \n is going to the next line and then printing the 2, which is the number. Again, \, it's going to next line, \n, it's going to next line. So we are defining one integer called choice. Whatever the user chooses, we are going to store it. First, we would like to see if the user is typing the correct number. So choice, if the choice is lower than 1 or greater than 4, we are returning invalid choice because it's not among the options. And the program execution is done. And if not, so if they correct something between 1 and 4, we are going to initialize x and y and ask the user to give us two numbers. So whatever they enter the first number, they push the enter button, and then they enter the second number, and then they push the enter button. So we store those two entered numbers in x and y using syntax. And then finally, we are going to define one integer called result. And based on the operations that they entered, we are going to call the function, the corresponding function, and pass two arguments, the x and y that the user gave us. Why we have the choice -1 here? Because in C++ we start from 0, so operations 0 means add, 1 means subtract, 2 is multiply, and 3 means division. Okay, so 0 means add, but if the user is entering 1, because we told the user to enter something between 1 and 4, so if the user wants to call the add function, they're going to enter 1. But here, if we put number 1, we are calling the subtract function. Okay, be careful about it. So 1 minus 1 will be 0, and the add function is going to be called. So basically, it is because we would like to be synchronized across all the blocks of code. We are using the -1 here, and then simply we are just putting the value of this function is called using this pointer, and these two numbers that the user gave us are going to pass as the argument to that function, and the result is going to be stored in the int result. Then we are printing the result. Okay, let me just run and see and analyze the code further if needed. So yeah, so we are here, select an option. We have one add, \n going to next line, and then 2 subtract, \n going to next line, 3 multiply, etc. So I would say 1 and I enter. When I put 1, it checks if it's the number is lower than 1 or greater than 4. It's neither, so it is in the correct range. It is going to show the message enter two numbers. I'm going to enter 10 and enter 12. It is going to return the result 22. So this is when I mentioned add, when I mentioned number 1, this number 1 is stored here in this integer choice, and this integer choice, which is 1 now, is going to be here. So 1 minus 1 is going to be 0. It means that we are having something like operations 0 pass the argument x and y. And when we have the operation 0, so the index 0 means the first element of this function pointer, and the first element is the add function, and the add function is simply taking these two arguments and adding them and returning them, because it's of integer type, it's not a void type, so there is a return value, so it is returning the value, and the returning value is going to be stored in the result integer, and we are showing the result. Let me run the code one more time. I call 2, so I would like subtract. So I would say the first number is 20 and the second one is 13, so the result is 7. So this is basically how we can have a more interactive coding exercise with the user, so you can also participate and check your code, and you see that it's becoming more nicer when it is interactive. Thank you for watching. Hello everyone, welcome back. Now we would like to write a program that processes an array of integers using a function passed as a parameter. And the program should allow applying different operations, for example, doubling the value or finding their square. To do that, we have one main function. We initialize an array, we get the size, we compute the size using the famous formula, and then we are printing out the original array. So far, nothing changes. It's like previous lessons, like the lessons in the array section. So we, using a for loop, we print the original array. So this contribution of this program comes from here. So we are calling a function called process array, and we are passing 3 arguments. So the first argument is the array itself. It's the array. The second argument is its size, and the third argument here is calling a function, so it's a double value. Let's go and read the process array. So when I go and read the process array function, it's of a void type, so it's not returning anything, and it is accepting 3 arguments. So the first argument is of type of array, it's of type int and it's array. The second one is integer, so it's a variable, it's just a number, so it is called size, so it's the size of the array, for example. However, the third part is the pointer that is for the third argument, and the pointer is accepting one variable itself, so one argument is within this pointer. So when we are calling the process array, we are passing the argument first, we are passing the array, the first argument, passing the size, the second argument, and we are passing the double value. It's a name of a function, so it is going to be treated as a pointer. So because the third argument of this function is a pointer, so now this pointer is pointing at this double value. So what is a double value function? Here we have 2 functions, double value and a square value. The double value is going to get one argument, it's an integer, and it is going to return the double of the variable that it is received. So in case that it receives, for example, 3, it is going to multiply it by 2. So 3 times 2, it is going to return the value 6. And a square is going to multiply the argument by itself. So if you pass the number 3, for example, it is going to have the multiplication of 3 times 3, so it is going to return the value 9. So here, when we are calling the process array, we are passing the array, because as the first argument, as the second argument, we are passing the size of the array, and then the name of the double value function. Because the first part is the array, it's correct. The second argument in this function is the size of the array, it's of integer, so it's correct. And the third part is a pointer. So now that it's a pointer and we are passing the name of a function for the pointer, so now the pointer of this function is pointing at this function, okay, and it is going to return this value. And what is the value that we are passing? The value that we are passing is these values. So it's the values, these are the values of the array. But how? When we are passing all these arguments to the process array, we are going to go through a for loop, because when we would like to access all the elements of an array, we need to iterate over all the elements one by one. To do that, we need a for loop. So the for loop starts from 0 and goes up to the size of the array, which is already passed. So as long as I is lower than the size, this loop is going to be, repeated. And for whatever the value of the array I is, so for example, when when I equals 0, it is going to call operation R0. Then I equals 1, it is going to have operations R1, for example, and the R0 equals this one. R1 equals this, okay? So basically what we are going to do here, we start from I equals 0. When we are in the I equals 0 in this loop, we are running and executing this line, and this line means this line, for example, when I equals 0. So we are basically mentioning that the first element of the array now needs to be treated using the operation pointer, and the operation pointer was pointing at this function because we called this function double value. So the first element of the array named ARR, which is 1, is passed as argument here for the double value function, and it is going to be times 2 multiplied by 2, and its resulting value is going to be now assigned to the first element of the array. So previously the array was 1, 2, 3, 4, 5. After this line, the array becomes 2, 2, 3, 4, 5. Okay. Then we increase the value of I by one value. So I equals 1, I equals 1. We enter the loop again. To do this line, we are having it here. We are mentioning the second element of the array ARR, which is 2, is going to be the argument of the pointer, and the pointer here is pointing at the double value function, and the double value function is getting the second element of the array, which is 2. So 2 times 2, the result is going to be returned. It is going to return the value 4 for us. So it is going to, now after executing this line of code, the array would look like this, okay? And the size of size of the array is 5, so I is going to go on from 0 to 5, okay? And we wrote what is going to happen for I equals to 1 and I equals to 0. So it is going to go through all the steps. Basically it is doubling everything, like 1 will be 2 as we had here, 2 will be 4 as we had here, 3 will be 6, 4 will be 8, and 5 will be 10 when we call the process function using this syntax. And then we are printing now the double value of the function. Let me run. Okay, we are seeing that the original array is 1, 2, 3, 4, 5, which is correct here because we were printing the original array here in the code. Then we call this process array function. And when we call this process array function, in the first iteration, the array becomes like this. In the second iteration, it becomes something like this. And in the last iteration, it is going to look like this, 8 and 10, which is exactly like here. So we computed the first element, the first two elements. So 2 is here, so 2 is here. We computed the 4 here, so the 4 here, and the rest is when this one for the I equals 0, I equal 1, these we analyzed here. Then I equals 2, I equals 3, and I equals 4. So we learned now how to, call the double function using the process array function. Now it is an array. It is having an array as the argument. But what if we would like to do the square? So if we would like to do the square here, sorry, if we would like to do the square here, we are having a function named square, right? It is just going to the difference is only for the math part. The rest is the same. So when we are having the square function, when we would like to make it a square and when we would like to call this function, basically we are writing the same thing. We are calling the process array, we are passing the array, we are passing the size, and then instead of double value function, we are calling the square value function. When we are calling the square value function, so this third argument of the process array is going to point at this square value function now. Doing so means when we are having a for loop here, we are saying that, okay, when I equals 0, we are going to execute this line, and this line means that the first element of the array, which is 1, is going to, so the pointer is going to point to the first element and it is going to call this square value function. So the first element is passed here, and the first element times first element, it is going to be 1. So now this time, let me write it down somewhere else. So square value, and this one was for double value. When it is doing that, I equals 0 until 5, and it is going to have the 1, the value 1 here. Then it is going to, then I equals 2, when I equals 1, sorry. So when I equals 1, it is going to call the second element. Second element is passed to this function. 2 times 2, it's 4. And then it's 9, then it is 16, and then it is 25. If I compile, okay, so we see the original array is 1, 2, 3, 4, 5, and the square one is 1, 4, exactly what we have here, 1, 4, 9, 16, and 25. Why? The reason is we are having the process array. We are having 3 arguments. The first one is the array itself, the second one is its size, and the third one is a name of a function. But because the third argument here in this process array function is a pointer, now this pointer is going to point to the named function, which is square value, and this function is going to take the element of the array that is passed to it and return its square. So in this case, it is going to pass the first element of the array to this, for example, function, and it is going to square it. Thank you for watching. Hello everyone, welcome to another coding exercise session. In today's session, we would like to write a program that defines several arithmetic operations and uses a function pointer to pass one of these operations to another function, which then applies it to two numbers. So to make it easier, I'm going to explain through the code so you would understand what it wants us to do. We have the same four functions here: add, subtract, multiply, and divide, and they're going to simply add two numbers, subtract two numbers, multiply, and divide two numbers. We know from previous examples this. In the int main function, however, we are only declaring two variables, and then we are calling the calculate function. So the calculate function is accepting three arguments. The first two arguments are two integers that are called a and b. These are separated by 1 comma, and this is the first argument. This is the second argument, and this is the third argument. Please note that the arguments are being separated using a comma. Okay? The first two arguments are easy. So these are simple. We did that before. They are just two integer variables. However, the third one is a pointer. And this pointer is now an argument of the calculate function. Previously, we defined a pointer that was it was an array of function pointer. So different functions were defined as an array, and this pointer was pointing to this array, and each element of this array was a function. Previously, it was something like that. But now, this pointer has become one argument of the calculate function itself. Now, what's the difference? The difference is that when we are going to call the add function, for example, we don't need to mention the we don't need to mention, for example, operations 0 and then x and y. Okay, previously we were calling the add function like this, but now we don't need to do that. The difference is here. So that pointer is now an argument of the calculate function, and if we would like to call the add function, we call the calculate function. In the first two arguments, we are passing the variables that are like 10 and y, 10 and 5, which are x and y. Then we call the name of the function, and this name is going to be assigned to this third part of the argument. So the pointer is now directly pointing to that add function. And when it does, it's going to call the function passed as a pointer. So it is going to, now the result of this line is this add function is going to be called using the x and y variable, and it is going to add x plus y, write x plus y, return this x plus y for us. Okay, so let me explain it one more time with another example. So here we are calling the calculate function. Three arguments are passed, each separated by a comma. Okay, the first two arguments here are these two, so they are variables of integer type that are x and y here for us, that are having the value 10 and 5. And the third argument here is defined to be a pointer. And when in the third argument that we are passing, we name the function and then call the calculate. We name the function that we would like to, we would like to be operated. So we name the function, and when we do that, when we put the name of this subtract function here, this pointer is going to point at this function. So it's going to, by this line, it is going to call the subtract function and then pass a and b, which are x and y, because x and y are a and b here and a and b here. So x and y are going to be passed to this subtract function. Why? Because the pointer is pointing to this function. Why it is pointing to this function? Because the third argument is a pointer, and we named the subtract function as the third argument. This is why. Then it is going to do the subtraction and return the result for us. So it is going to subtract a minus, do the a minus b and return the result for us. Let me just run the code. Okay, great. So here we see that we have the calculate, and calling the add function, it is having the addition. 10 plus 5 is 15, subtract is 5, multiplication is 50, and division is 2. So this was a very good example of a function that takes a pointer to another function as a parameter. Please go ahead and do these exercises yourself. They are very useful. They may seem simple for some people, they may look simple for some people, but they are complex in nature and very tricky. So please go ahead and do these exercises yourself as well, so you get used to calling using a pointer to call an array, a function, or a variable. It just comes with the practice. So practice makes perfect. Please go ahead and do it. And in case you had any problems, you can write to me in the question box, and I will be happy to help you out. Thank you for watching. Hello everyone, welcome to another coding exercise session. Now we would like to write a program that dynamically allocates memory for an array. Previously, we learned that we can declare and initialize an array like that. So this is the name, this is the type, this is the name of the array, this is the type of the array, this is the number of elements, and these are the elements. And when we have one element that is 0, it means that all of the 10 elements are equal to 0. So here we see that a declaration and an initialization of an array is done in a normal situation. But there is a drawback to this type of declaration. So we are having like an array with 10 elements. So we are using, for example, 10 bytes of our memory. But what if we are not sure how many elements that this array needs to have? So for example, if one user is going to use 8 elements, one user is going to use 5 elements, one user is going to use 2 elements of it. One way is to declare one array that is big enough, that is large enough, that can have enough memory to, for example, be used for a user that is going to use 8 elements of it, and for another user that is going to needs an array with 5 elements, and the last one needs an array with 2 elements. But here we are declaring an array with 10 elements, so we are not using our memory in a very optimized way, because sometimes we can ask the user to simply give us their elements of an array that they would like to have. In this lecture, we're going to do it later on in a few minutes. But before that, I am trying to show the drawback of this declaration of array. So this declaration, if we are having different users that are using our program, so one user may need to have an array with 10 elements, one with 8 elements, one with 5 elements, etc. So either we need to have an array that is large enough that we make sure that it is larger than the size of the arrays that are going to be chosen by our users, which is not a very efficient way. Or we can use another way and declare our array dynamically using pointers to let the user choose the size of the array. So if one user is going to use our array and they are needing only an array with 8 elements, we are going to dynamically allocate 8 elements for an array based on the input of the user. Another person is going to use our program, they need 5 elements, so we are going to declare an array with 5 elements. So as you see, we are giving dynamic memory allocation based on the user preferences. So it is a bit more customized. To do a dynamic allocate memory declaration for an array, we can simply declare it like this instead of this. So this is the name of the array, and this is of pointer type integer, and the size of this array is going to be put here, like it can be 5, it can be 8, it can be anything, and this is the type. So basically we are declaring a pointer that names array that can hold the address of the array, and dynamically allocating the memory for an array in the elements with this size and return the base address of the allocated memory. So this is how we can do it, okay? But we first need to ask the user what is the size of the array that you're looking for. To do that, we are initializing the size, we are reading the size from the user, and we are declaring and initializing our dynamic array here. And then when we have the size from the user, we are allocating an array with the same size as the user mentioned. And we are having a for loop to feed the array. So for example, the user says that I want an array with 3 elements. We dynamically allocate an array with 3 elements size, and then we are having a for loop from I starting from 0 until I is lower than size, and we are reading the elements of the array from the user here in this line, okay? Because we're calling the name of the array, and this is the ith element. So when I equals 0, it is going to store whatever the user is entering in the first element, then second element, then third element. And here we are simply just displaying whatever the user chose for the array. And finally, when we are declaring a dynamic array, we need to make sure, in order to deallocate the memory and or free the allocated memory, we need to make sure we need to use this syntax. So delete and the name of the array. So the allocated memory is now deleted. Let me run and we analyze the code further. Okay, so here it says that enter the size of the array. I would say like 3. And now it is showing me, okay, enter size element. So the size was something that I entered. Now it is printing enter 3 elements, because I entered I would like to have an array with 3 elements, or the size of 3. So basically whatever I'm going to enter, it is going to store as the first, second, and the third element of this array using this for loop. So I'm saying the first element is 4, the second element is 7, the third element is 2. And basically here in this for loop, it is printing the stored array that I used for my array. So I entered that I want an array with the size of 3, that the first element is 4, then 7, then 2, and it is now printing array elements are 4, 7, 2, exactly what I entered. So if another user wants an array of, for example, 5, they can have it like an array of size 5 and the elements are 1 to 5. So it is allocating an array with 5 the size of 5. So this is how we can use dynamic memory and use efficiently the memory allocation. The important thing, the declaration, we get the size from the user, so it is customized, and then we need to deallocate or free the allocated memory at the end of the program. This is basically how the dynamic allocation of an array works. Thank you for watching. Hello everyone, welcome back. In today's coding exercise session, we would like to write a program that dynamically allocates memory for a 2D or two-dimensional array. Let me first run the program and see how it works, and then we start analyzing the code. So basically it is asking to enter the number of rows and columns. So I would say 2 rows and 3 columns. It says enter the element of the two-dimensional array. I would say 1, 2, 3, 4, 5, and 6. So, and then it is printing the elements for us. So it is having 2 rows, as you see, and there are 3 columns. So the first 3 numbers are stored in the first row because there are 3 columns, and the second 3 numbers is going to be stored in the second row. But here is an example of dynamic memory allocation. So I chose to have like 2 rows and 3 columns. One could use, for example, 3 rows and like 2 columns, for example, and then entering the numbers. Oops, sorry. So then entering the numbers like this. So it is customizable. If we were going to use the normal declaration of the array, we should have chosen an array that is an array with the size that is large enough to consider all of the sizes and can contain all of the sizes for the input. However, using a dynamic memory allocation, we can have our array customized based on the user preferences. So now I want an array with 3 rows and 2 columns, and can do it, and you want another array, it can do it. So this is dynamic allocation. So efficiently we are going to use the memory. To do this program, we need to have 2 integers, rows and columns, and we're going to read them from the user. And then we are going to have a for loop for the declaration of the two-dimensional array. So basically this row is array of pointers where each pointer will later point at the beginning of a row of integers. So for example, if we are having in the input, if we are having 2 rows, something like this line will help us to have an array of 2 rows with the size of 2, which is the input of row, but we assume that it's 2. So it is going to give us an array of pointers. Each pointer is pointing at the beginning of each row. So now in case that the number of row equals 2, we are having 2 pointers. Each of them are pointing at the first element of the array. And then we are having a for loop here that it's a loop that is used to go through each pointer in the array. So basically it is going to go through this pointer in the first row and the second row because it is starting from 0, and it is going to continue as long as I is lower than row. So in case row equals 2, I equals 0 and 1 going to enter this loop. Okay. Then it is going to allocate memory for each row. So for example, for each row, for each pointer in the row, like we had a pointer here and a pointer here, memory is allocated for a row of integers with columns element. So if the number of columns are 3, it is going to allocate this size of memory of 3. Okay, if the number of, for example, columns are 4, it is going to allocate 4 elements of memory for this pointer pointing at 4, starting at 4. Okay, so this is how we are declaring a two-dimensional array. One more time, I'm going to review. So first, we are creating an array of pointers where each pointer is going to point at the beginning of each row. So if row equals 2, it is we are having 2 pointers, one pointing at 1 and one pointing at 4. Then we are having a for loop going through each pointer in the array. So we are having 2 rows and I starting from 0 as long as I is lower than row, we are having a for loop because for each row we are going to assign a memory. To do that, we need the number of columns. So in this case, the number of columns equal 3. We are going to give and allocate memory for a row of integers with 3 elements. Okay, this is how we do it. And this policy is extendable for example, a three-dimensional array, etc. We are going to have another for loop here. Then when we are having the declaration, we are going to initialize the array. So we are saying that enter elements of the two-dimensional array. So when I equals 0, we are going to have j equals, for example, 0, 1, and 2. If we assume rows equal 2 and columns equal 3, this is going to be the first iteration of I and all the iteration of j. So whatever you're going to enter, it is going to put it in the first row, first column, then first row, second column, then first row, third column. So this is why when I enter 1, 2, 3, it is having the first row is stored with 1, 2, 3. Okay, because we are having 3 columns only. Then when it is done, it is going to ask, the I is going to increase. So now I equals 2, I equals 1, and j again goes from 0, 0, 1, and 2. Therefore, we are having the second row, first element, second row, second element, and second row, third element. And this is why when we are having the 4, 5, and 6 here, okay? And then we are going to have another nested loop, one outer loop here, outer loop, and one inner loop that is going to print all the values for us. Again, I equals 0, it's for the rows, and this is for the columns. When I equals 0, j equals from 0 to 2, and it is going to print 1, 2, 3. Then we have endl, because this loop is finished. We have endl here. It is going to next line, and now it's there. And then we are going to print when I equals 1 and j equals 0, 1, and 2. So it is going to have 4, 5, and 6 printed. Let me run again. So I would say the number of rows 2, the number of columns 3, and when I enter 1, 2, 3, 4, 5, 6, we are seeing that the elements are printed exactly as we have here. Okay, so this is basically how we can dynamically allocate the memory for an array, for a two-dimensional array. But something to remember is to free the allocated memory. Here, because it is two-dimensional, we are going to have a for loop to delete the memory allocated for our array, I for the columns, and then the whole array itself of the array of the pointers. Thank you for watching. Hello everyone, welcome to this coding session. So in this coding exercise, we are going to discuss a pointer to another pointer. So if we need a function that updates the value of a pointer itself and not the value it points to, we need a pointer to a pointer. So for example, in this example, we are demonstrating how a pointer to a pointer works to modify address stored in a pointer access and modify a pointer. So we call this a pointer to another pointer, or a double pointer, we can say. Initially, we learned that this is how we initialize one integer, and we are giving the address of the integer to the pointer ptr. So by having this and sign, we are giving the address. And then this is the name of the first pointer. We are giving the address of this pointer to another pointer. And when we are having a pointer to a pointer, please be careful that you need to have 2 stars there. Okay. So let me just comment this part and start printing this part. So the value of x is now going to be printed, and then the address of the first pointer and the address of the double pointer. So here we are printing the value of x, and this is the address of x that is stored in the first pointer, in our pointer, and this is the address of our first pointer that is stored in the second pointer. Okay, so this is the value of x as it's printed. Let's review one more time. And this is the address of the x that is stored in the first pointer. Okay, and this one is address of the first pointer that is stored in our second pointer or double pointer. Okay, you see that the addresses are different. Okay, and now basically how it works is going to be like this. So basically we can use our double pointer to modify the value of x, because this pointer is pointing to this pointer, the double pointer is pointing to the first pointer, and the first pointer is having its point to the variable. So by modifying this, like we are typing down double pointer equals 100, we are going to have the x variable modified. Now, as you see here, the value of x, we are printing it here, it is 100 instead of 42 that was initially there. So basically, this is how a pointer to another pointer works, and we learned that the address of x is going to be stored in the first pointer also, and the address of the first pointer is going to be stored in the second pointer. However, directly using the double pointer or the second pointer, we can access the value of the variable x here and directly modify it. Thank you for watching. Hello everyone, welcome to another coding session. In today's coding exercise, we would like to write a program that access array elements using a double pointer or a pointer to another pointer. So we are having one simple one-dimensional array here that is named ARR. It's of type int and it is having 3 elements. And then we are having a pointer to the array. So this is how we're defining a pointer to the array itself, okay, to the initial, to the first of the array, to the beginning of the array, okay? And then we are having a pointer to this pointer. So a double pointer is defined here, and we are pointing to the first pointer, okay? Note that when we would like to point at the beginning of an array, we don't need the and sign in here. We just point at the name of the array. So basically, you just need to write down the name of the array. Then we would like to print and access its value. To do that, we need a for loop because it's an array of 3 elements. To do that, we are having I starting from 0 as long as I is lower than 3. So I is going to get the value 0, 1, and 2. And then basically we are having to have this line of code to access each element of this array. So one, because we are using a double pointer or a pointer to another pointer, we are having two stars here, but one star is outside of the parentheses. So the first star is outside of the parentheses because it is dereferencing the value obtained by adding I to the star PTR to PTR. Let me make an example. So basically what it does step by step is that this part of the code, it is dereferencing the PTR to PTR to get the value of the first pointer, which points to the start of the array. Okay, and this is dereferencing the first pointer, and then it adds the value I to the pointer value, effectively moving to the ith element of the array. So when I equals 0, here, this one is going to dereference the first pointer that is pointing at the first element because the I equals 0. Now that it is pointing at 10, we are dereferencing the double pointer because because now this part is going to point at the first beginning element when I is revealed, and then we are dereferencing with another or second star the double pointer here. Okay, and basically this is what I explained here. So dereferences the resulting pointer to access the actual value of the ith element of the array. So when I equals 1, this line is firstly pointing and dereferencing the first pointer, and we are adding the I. So now I equals 1, so it is this one is pointing at the second element, and therefore we know that the result of this parenthesis is the pointing at the second element, and then we are adding the second star here, or the first star before parenthesis here, to dereference the uh, double pointer here, that dereferencing the resulting pointer to access the actual value of the ith element of the array. And then I equals to 2, which means that this one is dereferencing the first pointer, and by adding the number 2, because it is pointing at the start of the array, by adding 2, 1 and 2, it is pointing at the 3, and using this code, the full code, now we are dereferencing the resulting pointer, which is now at 30, so we can access the actual value. So let me run. Okay, great. So you see here that it is now printing 10, 20, and 30. Okay, but let's do another test. To do another test, now I'm putting both of the stars in the parentheses to see how it happens. So basically what it is going to do is that it is dereferencing directly the first element, because now it is pointing at the first element. Okay, it is now pointing at the first element. So basically here with this, we are simply dereferencing this one that is pointing at the first element, meaning that this part is value is 10. Then 10 is being added to the value of I, which is 1 times 0, then 1, and then 2. When I run, you see that it is not printing the values of the array. It is printing 10, 11, and 12. Why? Because in each iteration, first it is dereferencing the first pointer that is pointing at the first element only. And then it is adding the value of I, which is value between 0 and 2. This is why here we are having first in the first iteration, this part equals 10 plus 0, we are printing 10. Then this part equals 10 again because it is pointing at 10. Then plus 1 because now I equals 1, and this is printing 11, and then 12. So this is not dereferencing the movement of the pointer. We are just dereferencing fully the first pointer, but having one star outside means that this part is going to dereference the pointer and also move the pointer to the next element using this I here, and then dereference the full value of the number. When it is pointing, when I equals 0, it is pointing at 10. When I equal 1, it is pointing at 20. When I equals 2, it is pointing at 30. And then when it is pointing, this part is pointing at 30, now we are dereferencing the resulting pointer that is pointing at 30, so we can see the actual output here. Yes, so this is what we were looking for. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to do some coding exercises regarding the typecasting. So basically, it means to convert the nature of a data type and its value. To give you an example, we simply initialize one float variable here that is called num, and the value associated to this data type is 5.75. Then we initialize one integer number called result and assign the value of num, which is a float, to the result. So basically in the output, when we print the value of the float number, which is num, we should see 5.75. However, when we assign this float number to an integer number, it is going to round the number to be able to print an integer value. Let's see. Okay, so here we see that the float number is 5.75. However, when it is assigned to an integer number, the value is 5. So when basically one float number is assigned to an integer number, or basically when we are converting the type of the data, it is going to round the number, so it is possible to print the integer number. So, and every time it is going to round down, unless we tell it to do the round up, it is going to round down the number by default. So round down the number of 5.75 is going to be 5. Now it is printed here. But instead of doing that, there is another way to do it. So another way to do it is to use typecasting. Typecasting the num directly. So typecasting is like this is the keyword for it. So the static underscore cast, then we have the type integer. So basically this num variable is originally a float number. Here we type down the destination, the target data type, which is integer in our case right now. And then we use the keyword static cast. So it is going to directly print the value of the num variable as it is an integer. So now we can run. Okay, so here we see that we're getting the same result. So in order to do it directly and avoid declaring a new variable and then assign the previous variable to the new variable here, we can directly use typecasting, static cast, and then the target data type in here, and then this is the name of the variable that we would like to perform the typecasting over it. So basically it's a very easy concept, but it is very useful. We're going to do some more coding exercises with respect to this typecasting, and also provide it to expand the exercises to pointers, for example, using typecasting for pointers. Thank you for watching. Hello everyone, welcome back. So in today's coding exercise, we would like to use a void pointer to access the value of a variable. Okay, so we would like to write a program using a void pointer to access the value of a variable. Basically, we haven't worked with the void pointer so far. So a void pointer is a pointer that we don't know its data type. It's a void, so it can get any type, but in the end, when we would like to access the variable, we need to do typecasting in order to understand the type. For example, here we are initializing one variable called x. It's of integer type and the value assigned to it is 42. Then we are assigning the address of that variable to a void pointer. However, when we would like to print out the value of this variable using the pointer, we need to use typecasting. Why? Because it's a void type, but this variable is originally an integer. And in order to access and print its value using a pointer, using a void pointer, we must use typecasting here. So basically the formula for using the typecasting as before, we learned it. So this part is simply the keyword. This is the target data type, which is of type int, because this is the variable is int, so the pointer should be int as well. Then we have one star afterwards, and we have the pointer in the parentheses, and one star before the parentheses will help us to access the value of the variable x here. So let me run. Okay, so using this code, now we learned how to use a void pointer and then access the value of the variable of integer type. So when it's a void pointer, we must use a typecasting. To do the typecasting, simply we have the typecasting keyword, the target data type, and also the name of the variable that we have here is the name of the pointer. We have one star after the target type and before the parentheses here. So in particular, this part, what this part is doing is like static cast int ptr. This part is simply converts the void ptr to a pointer of type int. So this part is written. Why? Because originally the pointer was of a void type here, because we initialized the void star. Okay, we write down this part in the code in this parentheses to convert this void pointer to of type integer. So basically what this part is doing is to converting the void pointer to an integer pointer. Okay, and also when this part of the work is done, we are having one star before the parentheses, and it simply does, after casting the ptr to an integer type, after casting it from a void to an integer here, the dereference operator, which is this star, is used to access the value of that memory location as an integer. Okay, so basically this part is converting from void to integer, and then this star behind this parentheses is going to dereference the operator star, the operator, so therefore the operator star is used to access the value of that memory location. So basically this is how we use typecasting for the pointers. Thank you for watching. Hello everyone, welcome to another coding exercise. In today's video, we are going to write a program that access the value of the variable y using a void pointer. So here we are initializing one variable that is called y. It's of float type and its value is 3.14. Then we are assigning its address to a void pointer. In order to access this variable, first we need to convert this void pointer to a float type, because when it is void pointer, it cannot directly access. So in order to do that, we need typecasting. To do the typecasting, we simply write down the static cast keyword. Then we are converting from void to the float, which is the target type. And this part of the code here basically does the converting from the void to the float. So this is the target variable. This is the pointer. So this is the target data type. And basically we are using float star because initially it was void star. So we would like it to be float star. So in this can make us to access the float variable. And then we have one star here that is going to dereference. It is a dereference operator that is used to access the value at that the value at that memory location as it is used. So let me explain it one more time after running the program. Okay, so here we see that we have a void pointer. We are accessing directly the variable y here. However, in order to access a float variable using a void pointer, this void pointer needs to be synchronized with the data type of the variable, which is float. To synchronize it, we need to convert it first. And then when we would like to convert it, we need to use the typecasting. So we type down static cast. And then in this part, we are going to type the target data type. So this is a void type, and the target is to have access to a variable that is of type float. Therefore, the target data type will be float. And then we are just typing down the variable that we would like to perform the typecasting over it. In this case, it's a pointer. So it was void star to declare a void pointer, but we would like it to be a float star, which means that it's a pointer to a float variable. And then we are having this dereference operator that we use to access uh, the memory location where this variable is stored in. Hello everyone, welcome to another coding exercise. In today's coding exercise, we would like to write a program that uses one void pointer to access different variable types. So we are initializing three variables here. One is of integer that is called a equals 10. We have the float b that is 5.5, and we have one character called c that is z. Okay, we declare a void pointer. But in order to access these three different variables using a pointer, previously we had to define three pointers. One to be an integer pointer, so it should have been something like this. My first pointer, and then we assign the variable a, and then a float a float pointer, my second pointer to assign the address of the variable b, and a char pointer, my third pointer c. Okay, now then when we are having these data types, we could print the first variable, and we could use the, for example, my first pointer handle. Okay, this way we were able to, let me just run the code. Okay, this way we were able to access an integer pointer using an integer variable using an integer pointer. So basically we are defining three pointers here to access three different data types. So here I printed out the value for the first pointer, then we could do the same print the second variable. It is my second pointer, and then print the third variable, my third pointer, and okay. So basically, in order to access three variables of different data types, we had to initialize three different pointers of the same type of the variable. So my first pointer is pointing at the integer variable a, my second float pointer is pointing at the float variable b, my third character pointer is pointing at the variable c, and here I am printing the values of these variables using their corresponding pointers. Okay, so and when I run, I see the result. See the result here. So first variable is 10, then 5.5, and then z as we wanted. However, in order to have a more efficient code, we could declare a void pointer. So we don't know the type a priori, so we just declare it. First, we assign the value, first we assign the address of the variable a to this void pointer. And then when we would like to access the variable a, we need to do the type casting, and we learned it before. So we use the static cast keyword, the target data type. Initially the pointer is void star, and now it should be int star because now it is going to access an integer variable. It is needed to be converted to an integer pointer, and this is the target variable, which is here a pointer, and then dereferencing the whole parentheses in order to access the variable a. Then we are storing the address of the variable b into the ptr, the pointer. So this is a float type, so when we are using the typecasting, we simply write down the keyword, and then we are having the float star because initially it was a void pointer, and now it is going to be a float pointer, and this is a pointer because we're doing the typecasting over the name of the pointer, so the name of the pointer is here. And then we are dereferencing the whole parentheses because we would like to access the variable b value, and then we do the same thing for the variable c. We do the typecasting to char, and we are printing. So let me run. Okay, so we see here we are having 10, 5.5, and z. However, instead of having three pointers, we are having only one void pointer. This is a very efficient way to manage the memory, because one pointer is going to get less amount of the memory as compared to three pointers. So we see that the practical usage of a void pointer is very respected and very useful and fruitful if we are not knowing that if we would like to have a pointer for different data types, or we are having a pointer initialized and we don't know that it is going to point only the integers, or integers and floats and doubles and characters. So in this situation, we are going to have a void pointer to access simply all the variables that we would like using a void pointer. Thank you for watching. Hello everyone, welcome to another coding exercise. Today we are going to write a program that uses a void pointer in a separated function to do the typecasting for us. Okay, so we are having one int main function and one print value function here. We start from here. We are initializing three variables, a, y, and z. A is of integer type, float is y is of type float, and then z is of type character. Okay, and we are simply calling the print value function. We are passing the address of our variables and one keyword. And let's go up and see the function. So the name of the function is print value. It's of type void, so it is not going to return anything. And as arguments, it is taking two arguments separated by a comma. The first part is a void pointer, and the second part is a type that is of a character. So basically, in the first call, we are sending the address of the variable x. So it is getting the variable x. When the first call is done for the function, it is going to store the address of the variable x in a void pointer, and then it is getting the character I, meaning that it's of integer type. And here we are having a switch function. It's a conditional function that says that if the type that is passed, which is now which is of type character, is passed, if it's I, do something, if it's F, do something else, and if it's C, do something else. So here we are having the switch over the type, and if the type, in case that the type is I, it means that it's an integer. It's a keyword that we define ourselves. And then we are saying that, okay, if it is I is passed, print out the integer value and then do the typecasting to integer. Because x is integer, here we are sending the address to a void pointer, and in order to access the value of this variable x, we need to do typecasting from a void type to an integer type. So we send this I message to the function saying that if it is I, it means that it's an integer, and then you need to do the conversion from a float type, a void type pointer to an integer, because the target variable is integer. So we use this simply, we use the keyword here. We are having the target type, which is integer pointer, and this is the pointer here we are having, because this part is, this parenthesis is going to have the target variable. In our case, it's a pointer, and then we are dereferencing the whole parenthesis in order to access the variable here. So the first call, it is going to convert the pointer from a void pointer to an integer type, and it is going to print the value of x. And then the execution is finished because there is a break afterwards. And then we are having the second call. We are putting the address of the variable y into it, into the void pointer as the first argument, and as the second argument we are sending the keyword f. Keyword f means here float, and we are saying in case it is f, the second argument that is passed is f, go and do the conversion from the void type for the pointer to a float type for the pointer, and use the static cast keyword, and then dereference the whole parenthesis in order to access the value of the variable y. Then we break, and it's the second execution of this function is finished. Then the third execution is going to be after the third call. We are passing the address of the variable z as the first argument for the void pointer, and for the second part we are sending the c character, and in case that it is of c, we mean that it's a character, so the program is going to do the typecasting from the void pointer to a character pointer, and then dereference the full parenthesis in order to have access to the value stored in z. Let me run the code. Okay, so here we see that we are having the initialization. We are calling the function for the first time. The address of x is passed as an argument to the void pointer, and then we are sending the I as it is an integer type. So we are having a switch condition here. Previously we learned from the beginner course that switch is when we are having different cases, it is efficient to use switch condition rather than if else condition. And we are saying that basically switch, if we would like to review it, basically in the switch condition we are having different cases, case for example 1, 2 and 3, And after each case, we put the condition and then colon, and we are going to execute whatever we would like to do, and we must put the break afterwards. So basically here we are saying that it's of I, so it says that in case that the character type, because the switch condition is type, if the type is I, enter this block of code and convert the void pointer to an integer pointer and access the variable x value. Then if it is F, come here, and if it is C, come here. So we see that basically the void pointer could access all the data types with different types easily. So this is a very good way to practice void pointers. Please go ahead and do the exercises yourself because they may look very easy, but you need to make errors to see where your weaknesses are and improve from there. Thank you for watching.